Mr. G here. We're going to be working through how to properly fill out your experimental design worksheet. This is worth 2 test grades, so this is a big part of our science projects. And what you want to keep in mind is that you, working through this experimental design worksheet, you're going to be able to recognize that, hey, you know what you need to know to get started. And you're going to need to get started on your project because time is going to be of the essence. So, where do we start? I'm going to be doing a fake example of one of my research questions to help walk you through how to do this. So if we go to our class research questions, I'm going to pull one of mine here. I'm going to pull the one here, my backup research question. I'm only pulling my backup research question because I think it's going to be more relatable to you. I think that some of these words and methods here you're not going to understand yet, whereas you're going to have a little more familiarity with this over here. However, you should recognize you're supposed to be doing your primary research question. So I'm going to X out of this and make this screen bigger here. So, you want to put your research question in here. Make sure it's your complete research question. Just because you posted your research question doesn't mean it's the best research question it should be. And some of you guys still need to work on making yours much more specific, and the points you get here are going to be based on the quality of your research question. So you notice that my research question, of course, is in the form of a question. Remember that a research question is just a hypothesis in the form of a question. So I've stated that when I'm placing either copper, zinc, nickel, lead, tungsten, aluminum, iron, magnesium, chromium, or cadmium, wow, look at how specific my question is. Those are all of the pieces of my independent variable there. When I place those in a solution is a mixture of substances this means 1 molar. That's a way of quantifying a solution that we're going to learn about later in this class. A solution of 1 molar silver nitrate. So that's very specific, isn't it? It's telling me exactly how much silver nitrate, this chemical I have mixed in water. So when I place those into this solution, which will cause the most pure silver to fall out of the solution. So I'm being very specific about what I think will happen, what I'm going to be measuring, which is my dependent variable. Which one of those will cause the most silver to fall out of the solution? Wow, that's pretty cool, huh? So, that's my research question. And that's what you need to do in this first part here. I'm just going to place that in there. The second part is you're going to state your independent variable. So what you're supposed to do is you're going to state what your independent variable is and how many variations you will have. Describe each variation. Okay, well, since I did such a good job of saying that in my research question, this is really easy for me, right? So my independent variable is different types of metals. I want you to say this in a complete sentence. Use good spelling and grammar. That's going to affect your grade. It's the wonders of spell check. And they are, so here's where I list each variation. Copper, zinc, nickel, make sure you spell these right, lead, tungsten, aluminum, iron, magnesium, chromium, cadmium. this bulleted list. I'm going to describe the variations. Now when I describe these, I'm going to just be very specific. Everything you should be doing is very specific, because what we're trying to do here is set ourselves up for success in designing our experiment, right? This is called experimental design because we want to make sure that we're putting all the pieces together to make sure our experiment is well thought out, so when we do it, it's really fast, really quick, and really easy. So I'm going to use a flat strip that is 10 centimeters by 1 centimeter by 1 millimeter. Now, we should know that we only want to have one independent variable, so this needs to be constant. So these all need to be flat strips that are the same. Okay, and that's what I need to do. Let's say what our experimental control is. Which variation of my independent variable is my experimental control? Sometimes we don't have one, but if we can have one, we better have one. Remember what an experimental control is. It's the normal variation, the one that we can compare all of them to. Well, is there a normal metal, a condition for a metal? Actually, there's not. So my experiment really can't have a control. There is no real situation where there's a control. So if there is that situation, I need to say it. And I'm going to explain why, just to make sure that I communicate to my teacher that I understand. My experiment cannot have a control because there is no real normal metal I can compare the others to. That's all I need to do. I need to put a... Very good. Okay. My dependent variable, what I'm measuring. Okay? So, if I go back and think about my experiment, I'm trying to see how much silver is going to fall out of solution. Now I know a little bit of background knowledge here about the chemical reaction that happens when metals are mixed with silver nitrate. You don't know that, but I do, and that's why I picked this. So when some metals are mixed with silver nitrate, they can do a special reaction which produces pure silver. So what I'm trying to do is see which one will produce the most silver. And so that's what I'm measuring, is the amount of silver. My dependent variable is the quantity of silver that will fall out of the solution the metals are placed in. See how specific I am? Now I only have one dependent variable here. You may have multiple dependent variables, so you want to explain what each one is. And it's great to have multiple dependent variables. We can learn more the more dependent variables we have. What are my units of measurement? This is super important. What am I actually going to be measuring? So if I want to know how much silver I'm producing, my go-to unit of measurement is going to be mass. I will be using units of grams. mass. Now, I'm going to be very specific again. I'm going to think about how this is going to work. We should be thinking about how this is all going to happen. My silver is going to be a little wet, isn't it? So what devices am I going to be using? I don't want to measure wet silver because that's going to not just measure the mass of the silver, but wet silver. So first, the devices I'm going to be using is I will first use an oven to dry the silver after filtering it out of the solution. I will then use my mass balance to get the mass of the dry silver. See how specific I'm being? And now I've completed that section. Now the constants. What do I have to control? Now, we want to control everything. We want only one independent variable. We want only one thing to be changed in our entire experiment, so we know that that's the only thing that affects our results. So, I'm going to make it so that you only have to pick 5 things. Now, the ones that we want to pick are going to be the ones that are most likely to affect our experimental results. So I'm going to think to myself, what are the things that I want to control that are going to be most likely to affect my results? Well, I have more chemical knowledge than you do, so I'm going to pick some things that may not come to you first, but that's okay. This is a learning experience for you. I'm going to make sure my metals are pure and not oxidized. Oxidation is rust, so I want to make sure none of them are rusted. That could affect my results. I should say R, not or. I'm going to make sure the volume of my 1 molar silver nitrate is the same for all my tests. Since the amount of silver nitrate that is in this the solution, the mixture, is the same, I still have to use the same volume, otherwise each metal will be exposed to more or less silver nitrate if the volumes are different. So I got to make sure the volumes are the same. What you may not know is that temperature can affect chemical reactions, so I'm going to make sure all of the tests occur at the same temperature. The surface area that the liquid is exposed to on the metal plates needs to be the same, because surface area affects chemical reactions. Again, something you may not know. So what could affect that is the reaction vessel, like the beaker that I'm putting these things in. So I want to make sure that the beakers used are all the same size and type. All right, I got one more that I need to put. I got temperature. That's good. Let's see, what's another thing I could make this? Well, I know that light can cause reactions, can have an effect on metals. And so I'm going to make sure that the light exposure and conditions are the same for all tests. And there's 5. I could go on with more, and I probably would if I was conducting this as a professional chemist. All right, so there's 5 controlled variables and constants. Trials. Trials are how many times you repeat the same experiment over and over again. Because what if you messed up one of your trials, like you set it all up and you did it and there was something wrong with it, you did something wrong. Well, if you only did one trial, you wouldn't catch it, right? Trials can catch random error and systematic error, which are 2 types of error that we talked about. So this is why we do trials. The answer is not 1, the answer is not 2, okay? If you do 2 trials, well, maybe you'll see something was messed up, but which trial was messed up, right? So the bare minimum is 3, okay? Me, I got enough supplies, maybe that I could do 4 or 5. Maybe your experiment has really expensive things and you can only afford to do 3. So the bare minimum is going to be 3. But I'm going to go ahead and do 5. I will do 5 trials. All right, what else do we want to say? That's all I really have to say, okay? If you're only going to do 3 trials, explain why, please, okay? Please explain why you're only doing 3 trials. Otherwise, I'm going to really question it, especially if I know that the materials that you're using are pretty cheap and inexpensive and easy to find, okay? Data tables, okay? 20 points. This is a big one, okay? You need to spend some time on this because this is super important. Your data is the keystone of your experiment. If you don't collect good data, you're not going to, your whole experiment falls apart. So you want to be collecting good data. So how do we create, I'm going to move this to a next page since this is going to, I don't need some room for this. So first we want to know how to make data tables in Google Docs. If you don't know how to do that, this is where I show you. So we go to Insert, Table, and we can pick how many rows and columns. And you can adjust the rows and columns after you have already inserted. So I'm just going to pick something random here. All right, so usually we have more than one data table that we use because we're collecting different types of data. So let's look back and see the kind of things that I have to measure. So I have various data that I'm going to be collecting. I'm going to be measuring my pieces of metal to make sure that they are indeed the right size and that they are indeed controlled, right? I have to make my silver nitrate solution. So I have to measure the amount of silver nitrate that I weigh out and the volume of water that I put it in. I need to measure the volume that I'm going to be putting in my beakers. So let's go ahead and make a data table for that. Let's see. So, oh boy, where am I going? All over the place here. So how about I make a data table for my silver nitrate solution. So, mass of silver nitrate. Volume of water. Total volume of solution. All right. So here, I've made a table for me to place how many grams of silver nitrate I'm going to need, how much water I'm going to need to make a 1 molar solution of silver nitrate, and then it'll tell me the total volume of solution I'll have. All right, so I'll have that data table that I need. I need a data table for my metal bars, okay? Or strips. So how many metal strips do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 metal strips. So I need a column for metal strips. I need a column for width, height, and length. All right, so metal, width, I need to add an extra row, height, and length. I can just format these all centered. Let's see if this works. It's not going to work. No. So copper, so aluminum, I think it was nickel, tungsten, I think lead, and I can't remember the rest. Zinc, iron, magnesium. Chromium and cadmium. Okay. Now, we want to make sure that we're putting units of measurement. All right, the width was in centimeters. The height was in millimeters. And the length was in centimeters. I think I missed that one. Yeah. All right. So I've got my table for that. Let me make this prettier. Now guys, the great thing about doing all this now is that when you go to do it when we have it later for the end results, we already have all these things made. We can just copy and paste to put in our final document. So we're measuring that. Then we want to measure the have data tables for our actual experimental data. Let's go on another page. So, a lot of times we do this by trial. So in our experiment, we want to measure the amount of time it took for us to get that we're going to be doing this over. I'll do this in how about hours? That needs to be constant, right? We can pick the time later. We don't have to put that in there now. We can put that in our procedure later. We'll use we already know from this data table the metal size used. What else do we need to measure here? We could do the volume of solution, volume of silver nitrate used, and do that in milliliters. Then we can do mass of silver produced in grams. All right. Let's see if I missed anything else. So there's my data tables that I'll need. Next section is calculations. What kind of calculations are we going to need to do? And this is actually going to remind me to put another section on my table. And I'll show you why. Average. We don't need a average time. Oops, I'm doing it wrong. I want to delete this. Where do we want to put the average? Let me think about this because I didn't do my. That's right. This is how. That's correct. I am doing this right. I'll explain. That's what I'm missing. See, we'll need to do a table for each metal, right? So we'll end up with, what was it, 9 metals. So we'll have 9 of these tables, and these will go, there'll be nothing here, nothing here. But here, we'll need to have the average mass produced for the trials. So 9 tables will average the data here. So calculations. We'll need to do a few calculations. We'll need to do the calculations for the silver nitrate solution production. You guys don't know how to do that yet, so I'm going to leave those blank. But if you did know how to do those calculations, I would expect you to put those in there. We will need to do the averaging calculations for the masses of silver nitrate produced for the trials. Right? So we would do trial 1 plus trial 2 plus trial 3 plus trial 4 plus child 5. Those are all masses. Silver. Underline all that for our division sign. Divided by 5. And that is going to equal the average mass per metal tested. Okay? So that's the calculation that you'll need to do for this lab. Right? Next is the graph. Another 20 points. What we'll want to do is we'll need to make a sketch of a graph, right? So here, what you'll want to do is first explain, okay, well, what data goes on which axis. So we should remember that our data for our dependent variable always goes on the y-axis, which means my dependent variable is going to be my mass of silver, in this case average mass of silver produced. My independent variable goes on the x-axis, which will be my metals. Then here I'm going to want you to put a picture, a sketch of what that would look like. I also want you to pick the type of graph that's best suited. For me, this would be a bar graph is going to be the best. So I don't know. Let's see, insert chart bar. Well, that's right. So one thing you need to understand in Google Docs is a bar graph is not really a true bar graph. They call them different things. I don't know why. You're actually looking for a column graph. That's a true bar graph, right? And so, let's see. Since I don't have this attached to actual data, since I'm making a fake, whoops, undo. Oh, Jesus. Let's try that again. There we go. Oh, why did it do that? Oh, that's why. Okay, here we go. So we're going to just fake it. We're going to say aluminum, Al, cadmium, chromium, copper, lead, magnesium. Let's see, 1, 2, 3, 4, 5, 6. Let's go back. Nickel, tungsten, zinc. Sorry. Nickel. What did I do? Nickel, tungsten, zinc. There we go. And we'll give them some, we'll stick with the masses that are here. Now I'm just going to put some random numbers. Silver in grams. We're not going to have another, we don't have another dependent variable, so this can go away. We always want to have a nice title. right? Our graph should have labels. Why they're not showing up? Let's see. Oh, here, chart axis tables. The horizontal axis, so we would have our metals tested. And then our vertical axis would be mass of silver produced in grams. And there we go. We have a nice pretty graph. It's fake. Nonetheless, it's there. Remember, we're getting our work done in advance so that later all you have to do is go and edit your data, right? Why does it have period? Oh, update. Got to update the graph. Okay. Next section is our materials. Probably the one that you want to get to as quick as possible so that you can know what you need to get for yourself, what you need to get from me, and we can work out any kinks along the way. So I'm going to need, something to put the metals in. It doesn't have to be a beaker. I mean, beakers, we use big beakers in science for a reason, because a lot of times the glass is a good thing, but a lot of times you just don't need it. So I'm just going to say beakers. You'll want to put the quantity. I got 9 metals, and so I'll need a minimum of 9. We'll want to say how much solution. These are 10 centimeters long, so we want to know how big we need, so I kind of know the size. So I'm going to say 400 milliliter beakers. I'm going to need my metals. So cadmium, zinc, aluminum, chromium, nickel, lead, copper. 1, 2, 3, 4, 5, 6, 7. I need 2 more. What was I missing? Magnesium. And oh, come on, Mr. G. Tungsten. We're going to need 3 each, or no, 5 each, since we're doing 5 trials. They need to be 10 centimeters by 1 centimeter by 1 millimeter. We're going to need distilled or deionized water. That's just pure water with nothing else in it. You can get it from Walmart. We'll go ahead and say 2 gallons. And that's to make my silver nitrate solution. I'll need silver nitrate. I'm just gonna, I know just from experience, I'll need at least 100 grams. Silver nitrate. I'll need something to mix that in, a jar to store it in. So I'll need we call them solution bottles. Really storage bottle. I'll need 1 liter storage bottle. There's a special flask designed to make these solutions called a volumetric flask. I'll need 1 of those. See, I'm being very detailed about what I need. I'll need things to measure these things with. I'll need a metric ruler to measure my metal strips, and also need a device called a caliper to measure the very small measurements of 1 millimeter. I need 1 of those. I need 1 of those. I need to do my quantities. I should put an X so you know that you're talking about quantities. Times 1 times 1. What else do we need? I need a thermometer to check my temperature, right? It needs to measure in degrees Celsius, because that's what we measure in. And we could also do conversions in Fahrenheit if you can't get from Fahrenheit to Celsius. You can learn how to do that. It's not hard. But why not get one in Celsius? We have those in the lab. You know, our mass balance, we have our homemade mass balance, but nonetheless we still need it. I have to list it. Mass balance times 1. We need an oven to dry those samples out. I said we need to do filtering, so I need filter paper to filter it out. We'll just get a pack of 50 of those. They're cheap, just coffee filters. And then we need a funnel to filter through. What about safety? My gosh, can't forget about that. We need goggles. Those are cheap. You can get them anywhere for a couple bucks. And then for this, we need gloves. Silver nitrate will stain your hands for quite a long period of time. And just get a box of gloves since we'll be in that. One box of gloves. I think we're good to go. Now, this part, the procedure, 50 points. I've already spent a lot of time on the video telling you what to go through, but here, friends, this is where you actually carry out your experiment. Usually, this is something that you write out as you're doing your experiment, okay? So I'm not going to spend the time to do this. This is going to be long, okay? It is a numbered list, okay? And you literally write out everything in detail, step by step. It says here, a third grader with no science background should be able to do this thing, okay? So you really want to be, probably best take a journal or a piece of paper and just write out the steps every single time you do it so that you can fill this out here. When you're done, and we do our final report, this is going to be a huge chunk of your grade. And so this is why you're doing it now, while you're doing the experiment, so that you don't have to sit back and remember it later. Your grade's going to suck if you try to do it then. You want to do it while you're doing your experiment. The last thing you're going to do is you're going to set up a sketch of your design. You're going to have a mental picture of what this is going to look like. So me, I'd probably have like 5 rows of all my 9 beakers drawn out with each metal strip sitting in those beakers. I'd have a thermometer drawn up with the same temperature. I'll pick a temperature if it's room temperature in Celsius. That's probably gonna be like 22 degrees drawn up there. I'm gonna have equal volume of I'm gonna have arrows drawn saying that silver nitrate, filled in each beaker. I'll have those metals sitting in there, and I'll have a clock, that shows that I'm watching the time, and I'm maybe have a label saying, checking every blah hours or hours, since that's, the kind of time frame I'm looking at, and I'm labeling everything. I'll label the different metals. I'll label the size of the beakers. I'll be stating that they're all the same size. You know, it should be very detailed, it should be legible. I want to know exactly, envisioning exactly what this experimental setup looks like. And you can do it if you're good with graphics. You can make it graphically. If you want to kind of do a collage thing and cut things out and make it kind of like that, you can do it. But I want it to I'm basically giving you options because I know not everyone is, you know, the neatest drawer and they're better with computers. So, but a drawing will suffice. So take a picture of the drawing, make sure I can see it. I may request that you upload it somewhere else if I can't see it, but all you do is you just drag and drop, or you can hit insert image. So I'll just take a random, maybe I can even see this. Let's do copper and silver nitrate picture, and let's just show you how to upload a picture. Let's pick a pretty picture, maybe with multiple trials in it. Here we go. So I'm actually doing an experiment that's not the same, but so I'm going to drag the picture, drop it. All right. So once you've got your sketch, okay, do not take a picture of somebody else's. Okay, there's no pictures. I'm just doing this as an example and showing you how to do it. All right. So that's what's going to go there. Okay. And then this is due in 2 weeks. Okay. Now, you should not wait to start your experiment in 2 weeks, okay? This assignment is just due in 2 weeks, so I'm giving you time to be working on this, okay? So, with the procedure, if you should be able to finish your procedure before you finished your experiment, okay? So, I'm expecting you to be starting your experiment within the next 2 weeks, but you should still be able to finish your procedure. So you'll have a good start on your experiment to get the first pieces down, and then you should be able to predict the rest of the stages in detail and get your procedure finished. So I don't think there's much of an excuse not to get the procedure done. Okay. So 2 weeks to get this done. You want to get started on your experiment in the next 2 weeks. I've walked you through everything you need to know to be successful in doing this. I'm going to post this document in the files section. Don't tell me that, oh, there was a picture there, Mr. G. I thought I could put a picture there. No, that was you not watching this video, okay? So, no excuses. Well, I guess I should just say. Okay, there we go. So that's it for the lesson on how to complete your experimental design worksheet, which is worth 2 test grades. Good luck. If you have questions, you know how to reach me.